My research is in an area of cancer predictions and predictions of efficiency of chemotherapy and other types of therapies for cancer and other diseases. You will see our future plans. But to start, the application of computer intelligence systems or any kind of artificial intelligence system in cancer or tumor diagnosis. First of all, my first projects were in applications of fractal and multifractal analysis in cancer diagnosis and prediction of efficiency of chemotherapy, specific chemotherapy. My collaboration team were from electrotechnical engineering university and medical faculty. I am PhD and professor of electrotechnical university, but I'm teaching also neural networks, kinetic algorithms, applied intelligent systems, applied artificial intelligence. My subjects on PhD studies are in area of medical image analysis, specific applying fractals and multifractals. So my co-mentor were Professor Jelena Vasiljević from Institute of Pathologists. I was working on Institute Mihailo Pupin, which is part of University of Belgrade. And nowadays I am working on University of School of Computing, University of Union, Jelena Vasiljević, and some my biography subjects, as I said. Okay, why fractals and multifractals? There are scientific papers about applying fractals and multifractals in explaining, first of all, in theory of chaos, in explaining in quantum physics, and that's why on some part of those theories we can explain carcinogenesis, why it is spreading like that. It's not so chaotic as it used to think with the fractals, and those equations we can explain somehow those multiplying of cancer cells. And that's why fractals and specific multifractals can explain, can have such a good results in research of cancer detection and distinguish between which is benign, which is malignant, which is health tissue. More benefits and advantages and importance of fractal and multifractal are those because there is no damaging of original image. There is no furlough of degradation, furlough of filtering, and that is really big benefits. Specific in cooperation in when we compare with other image analysis. So as I said, there is many nowadays scientific papers about applying fractals to explain those structures, pathologic structures of tumors, and that's why I think it's really good results. That's why this was my PhD, and it was really, interesting that pathologists they took biopsies from actually bone tissue, and they are searching for primary tumors in totally other tissues. My co-mentor Jelena Vasiljević, she told me that they have doubts for these three groups, for lung, breast, and renal cells. Renal cells are specific cells in kidney. So for these three groups, they have some doubts. And that's why we had searching for primary tumor in these groups. So primary lung, primary breast carcinoma, and primary renal carcinoma. And general hypotheses were that 6 multifractal parameters will be in correlation with these 3 groups, as I said. Okay. I used FRACLAC. It is a program from some university in Australia, with which I had cooperation. And I used for statistical analysis data registration. It is very good. FRACLAC, I found it much better than FRACLAB. FRACLAB is from Institute in Ria in Paris. And I had comparison of that 2 programs for my magisterium degree, actually. And I found it FRACLAC much faster for big data. FRACLAB, you must do it for each image and wait for results. FRACLAC, you can put big data and get results in few seconds or 1 minute. These were parameters for multifractal. There were 6 parameters. So general hypotheses were that all those 6 parameters will be in correlation with those mentioned 3 groups, primary cancer. It is really, how can I say, maybe sad that if they don't find where it started, if they don't find the primary tumors, it cannot be done anything. No therapy can be applied on those patients with metastatic tumors. So it is really important to find, but fast, to find that primary tumor. That's why it is that idea to apply some intelligent systems on that. So this picture, by the way, in background, it is, a picture of fractal, if you have heard, and the important characteristics of fractals is that any kind, if you zoom this picture behind, maybe here you can see it much better. If you zoom it, any part of this picture, you will get the whole picture. It is called self-similarity, and it is like hologram. So that's why it is. There are so good results for cancer detection, for prediction of chemotherapy, and in theory of chaos. So, as I said, general hypotheses were that all those 6 parameters will be in correlation with those 3 groups of primary cancer. I had 1,050 tissue images from bone, as I said, and I took those images, and of course, pathologists check it, but it's really hard to distinguish, you will see. So it is very hard job for pathologists and great, responsibility, because they are last in that chain of diagnostics of cancer. Pathologists, they say finally diagnosis. So it is really, really important to give them all help, and from computer science like this. So these are example. If you look through microscope, it looks like this when it is primer of renal cells, like this when it is started in breast, and like this when it is started in lung. Again, to say all those 3 and all 1,050 images they have been took from bone. It's really interesting that you take from bone and you are searching for totally another, tissue. So it's really hard for doctor, for pathologists to distinguish that, and I really admire them. And because of eye characteristics, human eye, that it cannot distinguish after some number of images, like for smelling perfume, you cannot distinguish after maybe fifth. That's why they need help from us to have a lower degree of those errors. There are some research, there are some data that after looking 10 of mammographic image, which is mammographic is with bigger resolution than with this which have been took from biopsy and looked through microscope, which is even harder. But there is statistical error over 50% over when they look mammographic images. That's why we need so much help from artificial intelligence. So we had results applying FRACLAC program. It is first transferred to binary, and we got like this: accuracy for lung primary carcinoma 78 over 78 accuracy, and other these results, which is very good because we had 3 groups. So for default groups it is 33%. This is very good. For breast carcinoma it is over 73. And for renal cells it is 76 and over. And actually I don't have it here on presentation, but I needed to change that general hypothesis on some other, because it came up that 5 of those 6 parameters multifractal were in correlation with those 3 groups. So I changed it in that hypothesis. Some of our other future research and now research is applying on other types of organs, on other types of metastatic. And we had some big project, I will tell you later about it, to apply it on all kind of pictures. Okay, so next project, very successful, was with the prediction of breast cancer chemotherapy response. We got those pictures right away after big awards they heard for me and my team. So we just got these images. So we had again 3 groups, as I said, with partial pathologic response, complete pathological response, and progressive stable disease. And these are results, which is very, very good, over 91% for partial response, over 82 for complete response pathological, and the similar over 82 for progressive stable disease. What does it mean? That because in this research it was all women, but it's usual for women breast cancer, although there isn't for men. But when they get patient on this way, you can you can have that personal health, medicine. You can say to that particular, patient with this, over 91%, we can say this type of chemotherapy will be efficient, efficient for you. It is really, great, and for doctor and for patient, because nowadays there is no such kind of computer objective some research. Doctor usually, at least in Belgrade, they usually recommend to all women chemotherapy. Maybe nowadays, maybe some new biotherapy, but nobody can tell that particular individual patient with such statistical response. It will be much easier, and for patients and for doctor, applying this kind of personal health. I would love that it is applied in the whole world. Okay, and some recommendation. It is for prediction for some other kind of therapies, comparing and mixing combination of multifactorial analysis, neural networks, especially CNN, convolution networks, and other types. There is capsular neural networks these days. And my idea is to have some universal open database and of microscopic images and radiation, MR, scan, all kind of images. That's why we had this proposal, and for startup and for innovation competitions, which had held in China. So we called it medical research platform, that we get in real time all kind of images from clinics. We offered to Serbian, the greatest private Medigroup clinics, that we get images in real time, all images, and we offer them statistical and other machine learning algorithms, because as soon as we have much more images, those softwares will be much precise, accurate, and we will get more new results for other kind of cancer or other kind of diseases. We want to work and for neural diseases such as Alzheimer or Parkinson or dementia or multiple sclerosis. And in Australia, when I was there, invited speaker, and for longer time, 40 days, there were some kind of concourse or tender to express some idea about algorithms for multiple sclerosis, and I offered this algorithm, mixed fractals and neural networks. Actually, as cancer is spreading, cells are replicating. I think multiple sclerosis is like algorithm in mirror. Those cells in those neural cells are distinguishing. They're diminishing. They are disappearing. Like cancer is multiplying. Here is disappearing those cells. But I think it's similar algorithm of fractals. So, because nowadays, until now, there is no precise some algorithms for multiple sclerosis. Because if you have algorithms, there is much possibilities to find cure. So I hope this algorithm will help in that, in neural diseases and other maybe diseases. So Other idea of that platform will be by to make that database for whole world data analysis, educational part of platform, not only for medical students, for computer science students, because I teach this and on my faculty, and sharing the knowledge between doctors. And doctors as patients, they all want that second opinion, not only patients, and they all want to be anonymous. So on this way, this platform would offer like that some possibilities. So as I said, data collecting and history, health history for patients, all images. That is really problem in Serbia, at least, because patients they go from one clinics to other, and you lose history before. And many patients, I think, don't know that uh, any images, any kind of X-ray, especially, there is some critical amount of those images, those X-ray that we can accept in whole life. After that, it's really dangerous to get some cancer or some other kind of disease. It should be educate, in school. It's not really so easy to get all those X-ray, starting with tooth and after. And of course, we for all research we have those a policy of data privacy. I don't know any name of patients, and I took I don't know thousands of images, so we have some unique number. So, and we have contracts with clinics about data privacy. Of course, it is obligated. Okay, I said that. So I usually take advantage of this conference to invite from whole world to cooperate. We can share those maybe images from clinics from USA or Japan and other Australia, wherever you are now, um, in order to get some unique and database and much accurate those algorithms and CNN and multifractals or whatever we use. So as I said, we have now cooperation with neural clinics for neurology, Vladimir Kostic, Medigroup, we are trying. Okay, and this is another my fractal image, one of favorite, and this is the favorite, the best. So that will be all for me. Do you have questions for me?